So let's take a look at what governs the strength of bond energy. Typically, one will recognize that if the bond length is long, then the overlap of the orbitals will actually be less extensive, giving rise to actually a lower bond energy. So hence, when the bond length is long, the bond energy drops. There are three factors that govern bond energy. I started with the first one on sigma and pi bond. Certainly, if you have a double bond, for example, the O to O double bond would definitely be stronger than O to O single bond. The next factor we look at is obviously the atomic size. If you look at the atomic size, say we were to compare in the case of Cl and compare to Br, and as actually Br atoms has a larger atomic size, we will expect its bond length to be longer. Because the bond length is longer, the bond energy would actually be smaller. The final factor that we look at is your polarity of covalent bond. This one we can take a look at the example of your HCl and relative that to actually Cl to Cl. You will find that in the case of HCl, we could argue to say that because chlorine is a lot more electronegative, so therefore it will actually attract the shared pair electron closer to himself, giving rise to actually a delta minus charge, while hydrogen becomes delta plus. So as a consequence of the slight difference in terms of their charges, you will find that they will electrostatically attract each other, and this electrostatic pull, all right, will bring the two atoms closer, and so the bond length will be shorter than expected and the bond energy higher than expected.